Hello my dear friends, how are you all? I hope you all are good and fantastic. So my dear friends, you are very welcome in our lecture number 5 of constructions. Okay my dear friends, I hope you will enjoy this lecture. So without wasting the time, let's start. Yes, so today we are going to discuss topic number 5, which is what? Which is construction of tangents to a circle. Construction of tangents to a circle. Okay my dear friends, so in this lecture we are going to discuss about tangents, that how to construct a tangent on a circle with the help of compass and ruler. With the help of what? Compass and ruler. Okay my dear friends, so my dear friends, we already know that what is tangent. In previous lecture we learned about the tangents. What is tangents? Okay, so a tangent is a line. A tangent is a line that touches the curve exactly at one point. Okay my dear friends, so let's suppose we have a circle like this. Okay, this is a circle. Okay, now let's suppose this is a point, and from this point a tangent is passing. Okay, so this is what? This is a tangent. It cuts the circle at just only one point. It touches the circle at just only one point. Okay my dear friends, I hope you get this point. So, and this point is called point of tangency. This point is called point of tangency. So my dear friends, I hope you understand these things. So the tangent to a circle is defined as it is also defined as the perpendicular to the radius of the point of tangency. Let's suppose this is center O and this is our radius. This is our radius, and it is perpendicular at the point of tangency. Okay my dear friends, I hope you get this point. So now my dear friends, now we have to see how many tangents can be drawn on the circle. Okay, yes. So my dear friend, there is a three cases. There is a three cases for the number of tangents on the circle. Okay, if the points outside the circle, how many tangents can be drawn? There are two tangents can be drawn. If a point is on the circle, then one tangent can be drawn. If a point is inside the circle, then we cannot draw any of the tangents on the circle. Okay, like this. Let's suppose we have a point inside the circle, point S. So from this point we cannot draw any of the tangent on the circle. Okay, so this is PQ is what? PQ is second. PQ is what? Second. And AB is chord. AB is what? Yes, AB is chord. So my dear friends, if a point inside the circle, then we cannot draw any of the tangents on the circle. Okay, so the second case is that if a point is on the circle, if a point is on the circle, then with the help of this point we can draw one tangent. How many tangents? Yes, in this case we can draw one tangent. Okay my dear friends, so now my dear friends, PQ is what? PQ is tangent. I hope you get this point my dear friends. So now let's move on. Yes, third case is that if a point outside the circle, if a point outside the circle, then from this point we can two tangents. We can what? Two tangents. Okay, so PT1 and PT2 are two tangents. Okay, my dear friend. So these three cases are very important. Now in this lecture, we will see how to draw these tangents on the circle with the help of compass and ruler. So we will see the two cases, when the points is on the circle and when the points is outside the circle. Okay, I hope you get this point. So now let's move on. Yes. So the most important is construction 11.3 is that to construct the tangents to a circle from a point outside it. From a point outside it. In this case, we use this case. Okay. In this case, point is outside from the circle and we are drawing two tangents from this point on the circle. Okay. So similarly, we are doing same thing in this, but with the help of compass. But with the help of compass and constructions. Okay, so my dear friends, there are some steps to solve these. Yes, to solve these problems. Okay, so let's see that now. So step of construction is that step number 1 is, first of all we have to consider a point A from the outside the circle with center O. With center O, like this. This is a circle. Okay, this is circle C1. Okay, now from center O we are taking point A outside of the circle like this. Okay, my dear friends, I hope you get this point. Now step 2 is join point A and O. Join point A and O and bisect the line AO. Now in this case we are bisecting the line AO. Okay, and we already learned how to bisect a line. In previous lectures we learned how to bisect a line. Okay, so for bisecting this line we have to place a pointer of compass at point A and open its mouth open its mouth more than half of this line and cut the arc from this point and this point. Now same thing with the same radius we have to place the pointer on point O and same cut the arc from this point and this point. So we have two intersecting points. Now we have to join these points. So this line will divide this line into two equal parts. So this is the bisector of this line. This line is what? It is the bisector of line AO. So I hope my dear friends you understand these things. So now let's move on. Yes, so the step number 3 is draw a circle taking P as the center and PO as a radius. Now we have to place the pointer of the compass at point P and with the help of pointer we have to open its mouth and place the needle of pencil at point A. So this will become the radius AP and with the help of this we have to draw a circle like this. So this will become a second circle. This is C2 and this is C1. I hope my dear friends you understand these things. So this circle will intersect at 2 points. Okay, this C2 will intersect C1 at 2 points at what? At C and B. C and B. Okay, my dear friends. So we have 2 intersecting points B and C on the circle with center O. Okay, and the fourth step is join the point A and B. Join the point A and B, A and C. Okay, we have to join the points A with B and A with C. Okay, so we have AB and AC are the required tangent. Okay, through point B and C on the circle. So my dear friends, these tangents AB and C are from the outside of the point A. So this is the method to construct the tangent from outside of the circle. So I hope, my dear friends, you are able to do any type of the question based on these constructions. Okay, so now let's move on. Yes. Why AB and AC are tangents to the circle with center on? Now, how we can say that AB and AC is a tangent? What is the reason? So the reason is that, now for proof this, join BO. Now we are joining B to O, and it is observed that AO is a diameter of the circle of center P. Now AO is what? AO is the diameter of the second circle. AO is what? Is the diameter of the second circle. Okay, so by this construction, angle ABO is an angle in a semicircle. Angle ABO, okay, is an angle in the semicircle. Okay, I hope you get this point. Yes. So now, my dear friends, therefore angle ABO is equals to what? 90 degree. 90 degree. So OB as a radius of the circle. OB is what? OB is the radius of the circle C1. Okay, and AB has the tangent through the point B. Okay, this is what? This is, yeah. So this is a perpendicular line. So we can say that AB is perpendicular to the radius OA at the point of B. So we can say that AB is what? AB is a tangent. Similarly, we can say that AC is what? AC is a tangent. So from this, we can say that OB is the radius of the circle with center O. With what? Yes, with center O. And AB has to the tangent through the point B. Okay, so my dear friends, this is the justification, this is the proof of this, why AB and AC are tangent to the circle with center O. Okay, so now let's move on. Yes, so my dear friends, now we have to draw tangents to a circle from a point on the circle. We have to draw tangents. We have to draw tangents to a circle from a point which is on the circle. Okay, so for this, first of all, draw the radius of a circle through the required points. Okay, first of all, we have to draw the radius. Now draw a perpendicular line to the radius through this point. This will be the tangent to a circle, like this. Okay, we have what? We have a circle and we have radius OP. Now we have to draw the perpendicular line from point P. Okay, so this perpendicular line is the tangents of a circle. Is the what? Tangents of a circle. So my dear friends, I hope you understand these things, how to draw the tangents of a circle. Okay, so now, so the next case is that when the center of the circle is not given, when the center of the circle is not given, and we have to draw a tangent to the circle from a point outside the circle, and we have to draw a tangent to the circle from a point which is outside the circle. So how to draw this? So the steps are, first we have to draw, the first step is that we have to draw two non-parallel chords AB and CD. First we have to draw two non-parallel chords like this. If you see this figure, there are two non-parallel chords AB and CD. these two chords are what? These two chords are non-parallel. Now next is draw perpendicular bisector for both AB and CD, and we know very well how to draw perpendicular bisector of these lines. Okay, so we are drawing the perpendicular bisector of AB, which will give this line, and we are drawing the perpendicular line of CD, which will give this line. Okay, you know how to draw it? Yes, from this point we have to cut an arc of more than half of the line from this side and this side, and same thing we have to cut an arc from point B with the same radius from this side and this side, so it will give line. Let's suppose this is L and this is M. Okay, my dear friend. So similarly we have to do from the line CD, and from these two perpendicular bisector we get a point of intersection. So the point O at which these bisectors intersect will be the center of the circle, because the radius is perpendicular to the bisector of chord. So my dear friends, I hope you get this point. So now, so the intersecting point of these bisector is what? Is the center O or the circle. Now we have a center, and follow the steps which we'll have done in the case 1, and you can draw the tangents of the circle. Okay, now let's suppose we have a point A, and we have to draw from this point, we have to draw the tangents from this point on the circle. So first of all we have to join this. Okay, and we have to draw the perpendicular bisector like this, and with the help of this point we have to make a circle like this, and we have two intersecting point. Now we have to join this point and this point. So my dear friends, I hope you understand these things, how to draw the tangents on the circle. Okay, so my dear friends, this is very easiest method to draw tangents on the circle. So my dear friends, I hope you don't have any doubts. So now let's move on. So now we are going to do some questions based on these topics. Okay, so first question is that now we have to construct a triangle. This is the question related to the previous lectures. Okay, construct a triangle of side 4 cm, 5 cm and 6 cm, and then a triangle similar to it whose sides are 2/3 of the corresponding sides of the first triangle. So 2/3 is what? This is a scale factor. So we have scale factor is what? Is 2/3. Okay, yes. So now my dear friends, first of all we have to draw a what? Yes, we have to draw a triangle. So A, B, C are the first triangle which having the side 4 cm, 5 cm and 6 cm. So with the help of compass we can draw easily these two sides, these triangle. Okay, so first of all we have to draw AB with the help of compass. Okay, now with the help of compass we have to place a pointer of compass at point B and cut the arc of 6 cm. Now similarly here we have to cut the arc of 5 cm. This is our 4 cm. Okay, so from this we get a point of intersection and we have to meet point A and point B. So this is our ABC is a given triangle. Now we have to make an acute angle. AX is a ray. We have to make an acute angle. Okay, this is a random angle. This is not a fixed. You can take any of the angle, but this would be acute. Okay, which is less than 90 degrees, which is the in between 0 to 90 degree. Okay, now we have to cut 3 points because the maximum number is what? 3. We have to cut, yes, 3 points, 3 equal points of 1 units. So here is A1, A2 and A3. Okay, now we have to join BA3, BA3, and from this this is a line BA3, and we have to make a parallel line at point A which is parallel to what? Which is parallel to BA3. So for making the parallel lines, we have to make the equal angle. Okay, so we have to draw this equal angle on this point with the help of compass. Okay, we can draw easily. In previous lectures we already learned how to draw a parallel line. So we have to so this is we have this intersecting point, and from this we have to join this. So we get a point B dash, and from this B dash we have to parallel line, which is we have to parallel lines parallel to the BC. Okay, so for this we have to make an equal angle like this. Okay, so we get a C dash point. So this is a parallel line. Okay, B dash C dash is what? Is a parallel line of BC. So my dear friends, we get a triangle AB dash C dash, which is smaller to the given triangle because the scale factor is what? Less than 1. Okay, if the scale factor is less than 1, then the constructed triangle is smaller to the given triangle, So my dear friend, this is the concept of the scale factor. If the scale factor is greater than 1, then the constructed triangle is bigger from the what? Yes, is bigger from the given triangle. I hope my dear friends you understand these things. So now let's do the justification of this question. Okay, now the construction of the given part can be justified as we have AB dash upon AB. Let's see, AB dash upon AB is what? 2 upon 3, because from this A to B dash we have two equal points, A1 and A2. So this is 2 and this is, and whole length is what? Is of 3. Okay, so we can write here as is 2 upon 3. Okay my dear friend, and similarly we can write it as we have B dash C dash is what? BC, which will give again 2 upon 3. Okay, and like this, B dash C dash, B dash C dash upon BC. And now we have to see in AC dash upon AC. AC dash upon AC, which is also equals to 2 upon 3. Okay, so from this construction we get B dash C dash is parallel to what? BC. So from this point, from this angle A B dash C dash is equals to angle ABC. Corresponding angles are equal. Okay, and now in triangle A B dash C and triangle ABC. Okay my dear friends, so now from this we can write it as A B dash C dash, which is equals to angle ABC, and angle BAC is equals to angle B dash as C dash, which is what? Which is common. So triangle A B dash C dash, okay, triangle A B dash C dash is similar to triangle ABC. Okay, by what? By double A similarity criteria. Okay my dear friend, so now therefore we can write as, so now we can write it as AB dash upon AB is equals to B dash C dash upon BC, okay, which is equals to BC dash upon AC by basic proportionality theorem. So this is one equation, first equation. Okay, Now in triangle, okay, A2B dash and triangle A3B, like in this A2B dash and A3B. Okay, my dear friend. Now in this triangle, we can write it as angle A2B dash is equals to angle A3B. This is what? This is corresponding angle. Corresponding angle. Okay, and we can write it as also angle A to AB dash, which is equals to A3AB. This is what? This is common. Okay, so from these two angles we can write it as triangle AA2B dash is similar to triangle AA3B by what? By double A similarity criteria. By double A similarity criteria. Okay, so now from this AB dash upon AB, which is equals to AA2 upon AA3 by basic proportionality theorem. By basic proportionality theorem. Okay, I hope my dear friends you understand these things, and we know that what? AB dash upon AB, which is equals to 2 upon 3, equation number 2. So from equation 1 and 2 we get AB dash upon AB is equals to B dash C dash upon BC is equals to AC dash upon AC, which is equals to 2 upon 3, and this will be written as AB dash is equals to 2 upon 3 times of AB, and B dash C is equals to 2 upon 3 times of BC, and AC dash is equals to 2 upon 3 times of AC. Okay, and this will be equals to what? Yeah, this will be equals to, yes, which? These conditions. Okay, my dear friends, I hope you get this point. So this is the justification of this question. This is what? Yeah, this is the justification of this question. I hope, my dear friends, you understand these things. Okay, so now let's move on. Yes, so these are the steps of this question. You can see here like this. Okay, yes. So the second question is that draw a circle of radius 6 cm from a point 10 cm away from its center. Okay, now we have to construct the pair of tangents to the circle and measure their length. So my dear friends, this is very easy. Okay, now in this case also we have to draw a tangent from the outside of the point. So this is the case of this. Okay, we have to draw the tangent from the outside of the circle. Okay, so let's start. So yes, first of all, see these steps of this construction. Okay, so first of all we have to, first step is that draw a circle with radius 6 cm with center O. Okay, my dear friends, like this. Now in this case we are drawing a circle. This is a circle C1. of radius, yes, of radius 6 centimeter with the help of compass. Okay, now locate a point P which is 10 centimeter away from point O. Okay, now this point P which is 10 centimeter is away from the point O, which is the center of the circle C1. Now third step is join the point O and P through line. Okay, now we have to join these points O and P. Okay, now draw the perpendicular bisector of the line OP. Now we have to draw the perpendicular line, perpendicular bisector of PO. Okay, so these are the intersecting points of arcs and we have to join these. So it cuts at point M. Okay, now next step is that take AM be the let M be the midpoint of the line BO, and okay, and take M as a center and measure the length of OM, and the length MO is taken as a radius and draw a circle. Okay, with the help of this point M and compass we have to draw this circle. This is circle C2. Now this circle intersect the C1 at 2 points Q and R. Okay, so the step 8 is the circle draw with the radius MO intersect the previous circle at point Q and R. Now join PQ and PR, which is the required tangent, which is what? Yes, which is the required tangent. So PQ and PR is the what? Yes, is the required tangent. So my dear friends, I hope you understand these things. Okay, yes. So now justification, let's see the justification. The construction of this given problem can be justified as we have to prove that PQ and PR are the tangents to the circle of radius 6 centimeter with center O. Means we have to prove that these lines are tangent on the circle C1. Okay, PQ and PR are tangent on circle C1 or not. Okay, so for proving this, from the construction, angle PQO is an angle in the semicircle. Angle PQO. Firstly, we have to join Q to AO, and this angle is what? Yes, is an angle in the semicircle. So we know that angle in a semicircle is a right angle. So it become what? Angle PQO is equals to 90 degree, because in a semicircle the angle is a right angle. Okay, so this will is, so now such that we can write it as OQ is perpendicular to PQ. Means this OQ is perpendicular to PQ. So OQ is the radius of the circle, okay, which is 6 centimeter, and PQ be a tangent of a circle, because these two lines are what? Perpendicular. Okay, and similarly we can prove that PR is a tangent of the circle. Similarly we can prove that PR is also a tangent on the circle C1. So my dear friends, I hope you understand these things. Okay, so now let's move on. So now question number 3 is construct a tangent to a circle of radius 4 centimeter from a point on the concentric circle of radius 6 cm and measure its length. Also, verify the measurement by actual calculation. So my dear friends, these steps are the same which we already seen in the previous questions. Okay, so like this, first of all we have to draw our circle C1 of radius, yes, of radius 4 cm. Okay, now we have to join another circle with the same radius, with the same center of radius 6 cm. Okay my dear friend, so this is the circle C2. Okay, now we have to take a point P anywhere on the circle C2. So let's take here point P, and now we have to join P2O. Okay my dear friend, now again we have to make the perpendicular bisector of the line, and we have a point M which is the midpoint of line PO, and with the help of midpoint of this line we can draw the circle C3. Okay, now we have two intersecting points on circle C1. Okay, so now we have to meet PO and PR. So these are the what? Tangents. So PQ and PR is the tangents. Okay my dear friends, I hope you get this point. So now my dear friends, we have to find the length of this tangent, and we know that if we draw two tangents from outside the outside point of the circle, then these two tangents are equal. Then PQ is equals to PR. We know this. So my dear friends, this is, first of all we have to join this line for measuring this PQ. Okay, and we know that this is what? This is perpendicular line. This is perpendicular line, and OQ is what? Radius of C1, and OP is the radius of C2. So we have OQ is equals to 4 cm and OP is equals to 6 cm. And we know that in triangle PQO, it is a right angle triangle. Right triangle, it is what? It is a right triangle. So my dear friends, we can write here as what? Yes, PO whole square is equals to PQ square plus OQ square, and we know the value of PO is 6 square. We have to find the value of PQ square plus what is OQ square? This is 4 square. So PQ square is equals to 36 minus 16. So this will become what? So this will become 20. Okay, now PQ is equals to under root 20. So this will give PQ is equals to, if we solve this, we get 4.47 centimeter. 4.47 centimeter. This is our answer. Okay my dear friend, so if PQ is equals to 4.47 centimeter, then PR is also equals to 4.47 centimeter. Okay my dear friends, I hope you get this point. So now let's move on. So now let's see the justification of this question. Okay, so the construction of this problem, of the given problem, can be justified as that if we prove that PQ and PR are what? Are the tangents. If we prove that PQ and PR are the tangents to the circle of radius 4 cm with center O on this circle C1. Okay, so to proving this, we have to join OQ. We have to join OQ and OR. So now my dear friends, from this construction, angle PQO is an angle in the semicircle. circle. Okay, so we know that the angle in the semicircle is a right angle, so this will become angle PQO is equals to 90 degree. Okay, and such that we can say that OQ is perpendicular to PQ. Okay, OQ, this line is perpendicular to this line, so OQ is the radius of a circle with 4 centimeter. Okay, now PQ must be a tangent of this circle because the radius is perpendicular to the PQ. Okay, so similarly we can say that PR is the tangent on this circle. Okay, my dear friends, I hope you get this point. So now this is enough for today, and we will meet in the next lecture with the next topic. So my dear friends, thank you very much for listening me, and take care and goodbye.